Hey guys, it's Mr. Dugal, and today we're going to talk about finding the volume of a sphere. And to start with, when finding volume of a sphere, obviously a sphere is circular in nature, but the biggest thing that we need to realize is that it's very different than finding volume of other three-dimensional objects like prisms or cylinders or pyramids, or even cones or pyramids. It's totally different than those, and that's mostly because we know, volume revolves around area of the base times the height. And when we look at a sphere, it has neither a height nor does it have a base. So we can't obviously find the area of the base. So when it comes to a sphere, we have to connect it in a different way to some of our three-dimensional shapes. I think the connection we do have is to that of a triangle and a triangular prism. Here's what I mean. With a triangle, we say that a triangle, a two-dimensional triangle, is the base times the height divided by 2, because we know that a triangle has 2 dimensions, a base and a height. Therefore, we divide by 2 because there are 2 triangles that can fit into a rectangle. When we take this out to a 3-dimensional shape that has a triangular height, such as a cone or a pyramid, any of our pyramids, we notice that the volume is area of the base, and instead of being like our prisms or cylinders where we just take that and multiply by the height, we take the area of the base, we multiply it by the height divided by 3. So 1/3 of the height. And the reason for that is we can have 3 triangular heights that would make up 1 rectangular height. And that's because it is a 3D shape. So for 3D shapes that are triangular in nature, we divide by 3. This again is our cones and our pyramids. These are our 3-dimensional shapes that have a height of a triangle. And for our 2D triangles, we divide by 2. Okay, very similarly, when looking at a circle compared to a sphere, with our circles, when we find area of a circle, we do pi times the radius squared. Our 2D shape, you'll notice, has an exponent of 2. In comparison, when we find the volume of a sphere, we do pi r cubed to the 3rd power for our 3-dimensional shape. So in this way, there is a sort of connection to the shapes that are triangular in nature. Additionally, we take that pi r cubed and we multiply it by 4/3. In an upper level secondary high school mathematics, you'll learn why it's 4/3, but for now, just an easy way to remember this that doesn't really do its due diligence in explaining why it is. But for now, to give you a way to remember this, is we remember the 3 because it's a 3D shape, and the 4 because when it comes to our globe, we often talk about spheres with our globe in terms of hemispheres. So we know that we have 1, 2, 3, 4 hemispheres, a northern, a southern, an eastern, and a western hemisphere when it comes to social studies. So we would do 4, because there are 4 hemispheres, over 3. Now the actual reasoning for where the 4/3 comes from and why this makes mathematical reasoning, again, this is something that you'll cover later in high school mathematics. So for now, we're just going to use the formula, and let's put this to work by putting some numbers together with it. All right, we're going to start. We have 2 different examples here. We have one where they give us the diameter, which will often be the case, and that's our first sphere. And we have our second sphere that gives us the radius. We're going to start with our second sphere that gives us the radius. Again, in this case, volume is 4/3 pi r cubed, where we have radius to be 9 in this case. So 9 to the 3rd power. We know that 9 times 9 is 81. And we find 81 times 9 to be 729. I'm actually going to leave it like this for now. And I recommend that you do the same, because often this number, your radius cubed, will cancel with the denominator to simplify. Obviously, if you have a calculator, that's a non-issue. But if you don't have a calculator and you're doing this manually, a lot of times it's easier first to check for simplification. In this case, it does simplify. 729 divided by 9 is 243, because I know that 3 goes into 72 24 times, and then 3 goes into 9 3 times. So I'm left with volume equals 4 pi times 243. When I multiply 243 by 4, I get 972 pi, and that's going to be feet cubed. I'm just going to leave my answer in this form. If I had a calculator, or if it was asked to take this one step further, obviously I could multiply by the shortened version of pi, 3.14, or the actual irrational pi itself. Okay, for our other example, we're given diameter. I'm going to use the formula again. Volume equals 4/3 pi r cubed. This time, in order to go from diameter to radius, I got to take half of the diameter. So I know that each radius is 6. The radius of this sphere is 6, so I go 6 cubed here. When I take 6 times 6, I square it, I get 36. And when I multiply that by another 6, I get 216. We're going to, again, leave it in this form for a minute. So we see 4/3 pi times 216. I do see that 3 goes into 21 7 times, and then 3 goes into 6 2 times, so that this can cancel. And I'm left with volume equals 4 pi times 72. When I multiply 72 and 4, I get 288 pi, and this time it's going to be meters cubed. So those are a couple of examples for how to find volume of a sphere. Again, the way to remember this is just like with area of a circle, how it was pi r squared because it was 2-dimensional. We're now going to have pi r cubed because it's 3-dimensional. We divide by 3. Helpful way to remember that is just, again, think 3D. And we're going to multiply by 4. Helpful way to remember that, again, is that we have 4 hemispheres on our globe. Hopefully this serves as a solid foundation for you to remember how to do volume of a sphere. Thanks so much for watching.